So we conclude this long segment on the data tapes that Julia provide us, dealing with dates and time. This topic itself is pretty large. Dates and times are implemented in Julia in the package in the module dates that is provided in the standard library, and would be themselves the object of a full lesson. We will take a pragmatic approach, trying to say how to do tasks rather than trying to be comprehensive on the subject. So, as you say here, there are two main tapes, date and date time. The first one is less informative because it contains information only up to the day, while data time, as the name suggests, it deals also with time. However, this is also more complicated because when you deal with time, you have to deal with problems like time zones and daylight saving. So this is the reason why we have two separate types depending on our needs. So let's see how we can create this object. First, starting from the current date or time. Here with today, we have a today date, a date, and with now we have a date time. And as you can see here, the tape is date and date item, and both are child of abstract time. Sometimes you may have heard another convention called the Unix time, but is the number of seconds from the beginning of the 1970 year, and we can get this one with the time, and it's just an integer in this case, is not a particular object. We can convert this integer to Julia date. Julia date time with a Unix to date time, and finally let's note that the time we have with now is a local time given by the local time set on the computer where you run the script, while the Unix time is expressed in the coordinated universal time, but this is the Greenwich time. But if you want UTC time also without passing through the Unix time, you can just give us parameter dates UTC to the now function, and you get back the time in UTC. This is all what we'll say about time zones in this segment, because the implementation of the functionality for time zones is on an external package that I give you here the link, timezone.jl. So aside of making a date or a date time from now, we're using the function now and today, most of the time you need to do from a string. So here is the way you do. You use the function, the constructor date or date time with the string, where you pass the string, and then you pass the way where that describe how your string is formatted. So here, for example, I'm making Christmas Day, and I'm using D for the day of the month, U for the name of the day in the month, U for the month name, and Y for the long 4-digit year. So here I'm saying to create a date object from this string. And by the way, if I do not specify here a formatter, I would have to write it in this way. So this would be the default. So I'm making, just because we'll need later another date, that is the New Year date. And similarly, I'm using I'm creating two date times Christmas lunch and New Year having dinner, where instead of specifying here the formatting, I'm using two well-known formats, ISO 8601 and another format. Here I give you the details of all the options you have to format this string, where you can go from the year to the months, days of the week, and up to the milliseconds. So here is how I create this date or date time object from a string. Another way is to create from some integers representing the year, month, day, and so on, and in this order. So here I'm creating a date for the 1st of January 2030, and you see that I do not need to specify all the other one. They default to the first day. And for a date time here, I'm doing the same. So sometimes it's more convenient to use this way to create the date or date times. So I have a date or a date time. What do I need for? Normally I need to extract some information. So I can, after I have it, I can write back to a string, and to do that I use the format function, where I will use the same formatters options that I described earlier, taking care that depending if I want to write with 1 or 2 digits, I will employ DD, or in this case I'm using 0, 0, 1, and M I'm using only 1, so this is 1 without the 0 in front. And for in the same way for date times. Other functionalities that with date and date time, okay, I can extract a specific year of a date. I can ask if it's a leap year. 2030 will not be a leap year. I can extract the month name, the day of the month, the day of the week, the day name in long, how many of these specific weekdays there are in that month. So now I know that here there are 4 Wednesday in the month of Christmas Day, that is in December. And here I can ask, okay, the 25 of December 2030, it is which of these 4 Wednesday? It is the 4th one. Then other functions only for date times are obviously hour, minute, and seconds. Okay, so here I can extract informations. Now, other things I can do, I can perform some arithmetics out of my date or date times in a way similar somehow to numbers. So first things, I need to extract a period. So if I take 2 dates, so this is two date objects, I obtain, when I subtract one from the other, I obtain one period expressed in days. And even if I get it longer, it will still be expressed in day. While for date times, if I subtract 2 date times, the results will be in milliseconds. And I cannot put together and make operation between date and date times. But what can I do? I can always convert a date object to a date time object. And I can even do the opposite, although I may lose information when I convert a date time to a date of event. And at this time, they are both date times. I can get the results in milliseconds. So both periods that I have here, they are So there are different objects. The first one between dates is a day object, and the other one between date times are milliseconds. And these you can see here, the day and the milliseconds, they are here. They are both child. So the first one, day, is a child of date period, and milliseconds is a child of time period. But both are child of period. So period is a top level type. We'll see types again, custom types in another segment, but you can intuitively see here that we have a hierarchy where period is at the top, and then we have date period, year, month, week, and day are childs of date periods, and then we have time period with these other types. And you cannot convert the object to something here like an year, but you can do the opposite. So you can convert a date time. Sorry, you can convert a day period in milliseconds. And you can also get canonicalized, and here you have the results in terms of, so this was several days, 1000 something days, and you can see that the type is compounded period. Now, it's not easy to, so you have this period in 1600 days. You may be tempted to get a function that extract the number, so that easily answer, okay, I have 1619 days. How many years it is? How many months it is? How many weeks it is? Weeks is fine. It's the only things you can get it pretty easily, because weeks are 7 days and are fixed. But it's not easily to respond to the other questions, because the period here, this object called the period, it doesn't have the starting of the period. It is only really an expression of numbers of days, and so the number of days in a month, the number of days in a year change. It's not constant. So to really answer these questions, how many years there are here, you would have to know, to have the information not only on the number of days, but also on the exact date when this period starts. So period doesn't allow to easily export the numerical of number of years, number of months, and so on, but are very useful to make arithmetic with dates, because when you sum a period to a day, to a date, sorry, when you sum a period, like and you create a period, for example, with the constructor here, to a date, now here you know exactly which date it is, and so plus 1 year where you go, or plus 40 days where you go, because you have a reference to exactly when the period started. So you can make easily arithmetic. So you can make next Christmas, but you have Christmas Day plus 1 year, or Christmas present opening time, so after you eat plus 3 hours. And to do this one, you use the constructors of these types. And you can even ask which is the weekday of today plus 100 years, using something like this. Sometimes you want to have ranges of dates. So, for example, here a semester is every 6 months. So, in a way very similar to integers range, where you have the from period, the ending of the range, and the step. Here you have the same. You have a date describing the beginning, a date describing the ending, and a period describing the steps. So every 6 months from this date to this other date. This is iterable, and you can collect it in the usual way to have an array of the dates that respect this range, that correspond to this range. Finally, sometimes you want to make some adjustment of your dates. So you want, for example, to know which is the previous days that respect some certain criteria in relation to a certain date. So we use for this one toPrev and toNext, when the first argument is an anonymous function describing the conditions that you want to obtain, and here is the date of the reference day. So this function will loop and take iteratively every date before Christmas Day, and will check that this one is true, and when this is true, we return this specific date. So here we check where the day name is Sunday, and we look back from Christmas Day all the days before till this is true, and in case of 2030 Christmas, it is the last Sunday before Christmas is the 22nd. Exactly the same things for toNext. Here we want to say which is the last day of this month, so we take today, and then we go up, we add 1 day to this day, and we say if the day plus 1 is day of the month is equal to 1, D is the last day. So if I do here, time of writing is 31 January 2022. Finally, we conclude the discussion on date and times and the whole segment, the whole long segment. With these functions, you can find the first or the last weekday of either month or year, depending what you pass, of a given date. So here you give a date, today, for example. You give which is the day of the week, 1 for Monday, 7 for Sunday, and we say find the previous one of the last. Sorry, the first one is to first. You find the first Sunday of the year compared with the year of this specific date, and here you find the last Tuesday of the month. Which month? The month given by this specific date, and in this case is the 25th of January and the 2nd of January. So here we discussed all the different types that Julia provide already to us, and next we will discuss how to work with given these types, how to work with these types, and we will continue to see how we can define our own types.